Hey learners, what is up? Let's learn something today from Master J. For today's video, we are going to talk about other terms related to sets. First, let's have finite set. Finite set is a set that has a fixed number of elements, meaning the number of elements are limited. Consider this example. Set of whole numbers between 20 and 25. Let us name our set as set X. Since the elements are whole numbers between 20 and 25, we have 21, 22, 23, and 24. This is an example of a finite set because, as you can see, the elements are countable and the given set has a last element. If we have finite set, we also have its counterpart, the infinite set. Infinite set is a set whose elements are unbounded or infinite, meaning the number of elements are unlimited. Take a look at this example. Set of even numbers greater than 4. Let us name our set as set Y. As you already know, even numbers are numbers that can be divided by 2. Since the elements are even numbers greater than 4, we start with 6, 8, 10, 12, 14, and so on. If you notice, we have no last element. That is because the set is unbounded. There are unlimited even numbers that are greater than 4. So in an infinite set, the elements are not countable, and the given set has no last element. In an infinite set, we use 3 dots called ellipses. Putting an ellipsis means that the elements are never ending or they keep on going. Now, let us have these examples. Set of numbers which are multiples of 5 and set of vowels in the word generous. Which among them is a finite set and which is considered an infinite set? That is correct. The first one is an example of an infinite set while the other is a finite set. Let us name our first set as set M. Since the elements are multiple of 5, we write 5, 10, 15, 20, and so on. As you can see, we have no last element. The elements are never ending. That is why it is an infinite set. For our second set, let's name it as set W. The elements are vowels in the word generous. Therefore, we have E, O, and U. Remember that the same elements are written once only. Since the elements are countable and the set has a last element, the given is indeed an example of a finite set. Next, we have what we call universal set. It is the set that contains all the elements under consideration. It is the set where the elements of the other sets are taken from. Universal set is usually denoted by capital letter U. Let's have this example. Let U, or the universal set, have the following elements: 5, 6, 7, 8, 9, 10, 11, and 12. Find the set of all prime numbers. Before we find the set of all prime numbers from our universal set, remember first that prime number is a number greater than 1 that has only 2 factors, 1 and the number itself, like 23, because only 1 and 23 can be multiplied to get 23. 17 is also a prime number. 17 times 1 is 17. There are no other factors to be multiplied to get 17. However, 20 is not a prime number. Because aside from 20 and 1, there are other factors like 5 and 4 that can be multiplied to get 20. Let us name our set of prime numbers as set P. From our given, we can see that the only prime numbers are 5, 7, and 11. And these elements are taken from the universal set. But in reality, we have many prime numbers. We only come up with 5, 7, and 11 because we have a given universal set that contains all the elements under consideration. Now, we have null set. It is a set that has no element. In short, it contains nothing. That is why it is also called an empty set. Null set is denoted by this symbol, while empty set is denoted by this symbol. Let's have this example. Set of whole numbers between 7 and 8. Let's name our set as set F. Obviously, there are no whole numbers between 7 and 8, only decimals. So therefore, this is an example of an empty set, or we can also use the symbol for null set. Take a look at these other examples. Set of months that start with letter C. Clearly, there are no such months. So, we can represent it as an empty set or null set. The next one, set of vowels in the word psych. As you can see, there are no vowels in the word psych, not a single one. Therefore, it is an example of an empty set or null set. Lastly, we have cardinality of a set. Cardinality of a set simply refers to the number of elements contained in a set. For example, if we have set T with the following elements, we can say that the cardinality of set T is 6 because it has 6 elements in it. Just like what I've said, cardinality simply means number of elements. In symbol, we can write the cardinality of set T like this. We write small letter n, then enclose the name of the set with parentheses, followed by equal sign, then the number of elements. This is read as the number of elements in set T is 6. Another example, we have set C with the following elements. Based on this, we can say that the cardinality of set C is 3 because it has 3 elements in it. Again, in symbol, we can represent its cardinality like this. For our last example, we have set A with the following elements. If you notice, 3 dots were placed in between the elements. This does not mean that the elements are never ending. We only put an ellipsis in between elements if the list of elements of that particular set is too long. We only use it for convenience in writing. In this case, obviously, the elements are letters in the English alphabet. So, if we count from A to Z, we can say that the cardinality of set A is 26 because it has 26 elements in it. In symbol, we can write it like this instead. So those are the other terms related to sets. Before we end our video, take note of the following. A finite set has fixed number of elements. An infinite set has no last element. A universal set contains all the elements. A null set has no element. That is why it is also called an empty set. Cardinality is the number of elements in a given set. So there you have it, class. I hope you learned something from our video and thank you for listening. See you again next time, masters.